As your projects get larger and you start to have lots of objects moving around and changing over time, organizing things can start to become a challenge. To address this challenge, we can take a new point of view based on objects. In this video, I'll give you an overview of the ideas, and then in following videos, we'll look at everything in much more detail. The ideas that we'll be talking about are generally called Object-Oriented Programming, or sometimes just OOP for short. The interesting thing about Object-Oriented Programming is that it doesn't give us any new capabilities we didn't have before. There's nothing you can do with OOP that you can't do using all the techniques we've already seen. This is just a different way to think about and organize your program. People have learned over the years that when programs get big, this is a really good way to think about them. Suppose that we're creating a simulation of planes on a runway. On the left, I have a simplified air traffic control tower, and of course, in the bottom right, we have planes making their way to the right and then up. The way we think about this is that the air traffic controller sends messages to the pilots of the planes, telling them what to do. What sorts of things might the air traffic control people say? Well, in our simulation, we can keep it simple. Maybe we just tell the plane to go forward slowly or quickly. Maybe we tell it to stop or wait. And of course, we can tell it to turn right and turn left. And let's say that these 6 things are all we need for our simple simulation. Now let's think about each plane. What does the pilot of each plane know? Well, he knows his own plane's location and heading and speed. And probably other things too, like color and size of engine, but we're not going to worry about that for now. So each plane knows its own location, heading, and speed. So let's actually stick that little badge on each plane. Now all of the planes can respond to all of these messages, but of course each plane has its own little packet of data telling it where it is, what direction it's going in, and how fast. Let's take a look at a typical message. So the air traffic controller first identifies which plane it's talking to. So first it says, "Hey, red plane, I have a message for you." The message is go forward slow. So it sends that message to the plane. The pilot hears it, he understands the message, and in response, he goes slowly forward. Now we want to move each of the other planes into position. So the air traffic controller talks to the blue plane and it says, "I need you to go forward slowly." So the message gets sent, the pilot hears it, interprets it with respect to his own plane, and goes forward slowly. Notice that he's now at the end of the runway. So a responsible air traffic controller will send another message. "Hey, blue plane, I need you to turn left." So the message goes out to the pilot hears the message, interprets it properly, and turns his plane left. And that's the general idea behind object-oriented programming. We imagine our program to be made up of objects, each of which knows something about itself, and we send a message to that object telling it how to behave. I'm using a lot of different words here, but there is a real vocabulary for this approach, so let's take a look at it. Here we have the messages that we can send to our planes, and these are often called messages. Sometimes these are also called methods. The planes themselves all belong to a class. It might be the class of airplanes or the class of small planes. The individual planes are instances. So we might say that the red plane is an instance of the class plane, and it responds to the messages or methods in the yellow box. The key thing to keep in mind is that every instance of a class, in this case every plane, has its own packet of data, but all the instances of a class, that is, all of the airplanes, respond to the same batch of methods. The way we send a message is we use a special syntax, and I'll show that to you now. It's going to look familiar because we've seen this a few times already. To send a message to an instance, we first name the instance, follow it immediately with a period, and then we send it the name of the message. And this is all smushed together with no spaces. So if we wanted to tell the red plane to go forward slow, we would write iconically this way, red plane dot _slow. In processing code, we would write something like this. Red plain is the name of the variable that represents this instance. _slow is the method or the message. We put a dot between them, and it turns out we're going to see that _slow will be implemented as a normal function, a normal routine. So it takes a pair of parens, and any arguments that it might take go between the parentheses. Sometimes we say red plain is the target. So we might say, I'm sending the message _slow to the target red plain. We also sometimes say that we're invoking the method _slow on red plain. There are a lot of different terms for this, and you'll hear a lot of different language, but it all generally has the same idea. We're sending a message to an instance. Let's now take this from the abstract to the concrete and see how it would look in processing code. I'm going to use a running example not of a plane, but of a car. And we'll assume a car can do the same sorts of things we saw for the plane. It can go forward, it can turn right, and it can render itself. That is, it can draw itself. When I think about the message to send to an object to cause it to draw itself, I tend to avoid the word draw because processing uses that as a keyword for the routine that draws a frame. So I use a synonym, and the synonym I like is render. The car itself remembers a few things about itself, its position and its color and that sort of thing. In part 2, we'll see how to actually write the code for a new type of class car.